Hi, I'm Deb, and my official name is Inyolua Raji. Try to say that 3 times fast. I'm here to talk about debugging discriminatory ML models. So like Sarah mentioned, I'm from the University of Toronto, and this is work I did with Joy Buluamwini at the MIT Media Lab. And I'm going to be talking about a follow-up study we did on her work with gender shades. So first, I want to sort of ask the question, what does it mean for a model to work? What does it mean for a model to be functional? Is it just performing, above 90% accuracy on a holdout validation set? Is that what it means for a model to work? And I'm going to talk about a couple cases where that's true, but it doesn't work. So one is, sorry to anyone here that works at Facebook to bring this up, but this is a recent case where Facebook was found to enable sort of the discrimination of different populations through their recommendations of ads by enabling advertisers to sort of filter out different populations. So the recommendation system did exactly what Facebook wanted it to, but does that mean it worked? Another example, recent example, is there was a recent report that Amazon's internal recruitment tool was found to be biased against female applicants for software development roles. Again, a model that probably, by all accounts was tested, but did it work? Another case, Princeton Review's sort of automatic pricing model was found to be biased against particular populations of particular zip codes, and those zip codes actually matched to Asian American communities. So again, a model that supposedly works but doesn't quite. And then a very, very recent example was a recent paper on Archive where they found that up to 8 image recognition models were worse at detecting pedestrians of a darker skin tone, kind of putting them at risk if this technology was sort of integrated into any self-driving car software. So again, a model that clearly doesn't work. And I could go on for ages. There's so many examples of machine learning models explicitly discriminating. In those previous examples, all of those were illegal levels of discrimination, and really putting vulnerable and marginalized populations at risk. These are fatal flaws in the system itself. This is worse than overfitting. This is something that can actually affect a human life. So these are very clear flaws, and it's enough to sort of restrict deployment and be factored into the development cycle of the model. So it's to put super simply, a bug. It's an element of the model that's not functioning. So is it possible to debug this? Is it possible to sort of think about and understand the discrimination that these models are capable of? Yeah, the short answer is no. I think this is sort of like a disclaimer slide too, where I'm not going to pretend that some of these issues aren't related to institutional biases and discrimination, aren't related to sort of fundamental corporate biases. All of this is much more complex than simply debiasing the fundamental functions of your model. But that being said, the software debugging process is sort of this interesting analogy or interesting way to think about and approach this idea of auditing these models for discrimination. And there's a lot of steps in the software development cycle and debugging process that we can use to sort of inspire algorithmically auditing these machine learning models and commercial APIs for the discrimination that we see. And sort of treating the discrimination as a bug for the purpose of identifying it and reporting it and fixing it appropriately. So yeah, super high level, my interpretation of the software development debugging procedure is sort of, you find the bug, you report it, you fix it, and then you sort of attempt to patch any procedural issues and prevent future misuse. So, the first issue is, how do I find the bug? And this whole presentation, I'm going to talk specifically about gender shades and the issues that we were dealing with. So we were dealing with issues of classification bias, where you have a model performing differently for different segments of the population. So I'm going to talk about that specifically, but I'm going to also kind of just mention some other forms of bias and other ideas related to gender shades, just to kind of give a call out or shout out to those ideas. So first, like, how do you identify these bugs? How do you identify when a model is discriminatory? I'm just going to kind of talk about the specific type of bias that gender shades was dealing with, which is this idea of label representation bias. So this is me, looking up healthy skin on Google Images and seeing that, okay, men can't have healthy skin, and darker skinned women can't have healthy skin according to Google Images. So this is often how, when you're sourcing images for a machine learning model, you sort of take the default. And that's very media influenced, and that media influence results in something like this. So first of all, like, how diverse are sort of the data sets that we're using now? And the short answer is not at all. So this is a study done by IBM's Diversity in Faces group, and they found that you would have up to 80% lighter images, and usually skewing male, but also skewing female in terms of the demographics of some of these popular data sets. Another thing that we saw was that the data sets are also very skewed in terms of age. So you see that this is, again, probably a byproduct of the media influence. This is probably the average age of models, of image models. So you can see that like actual fashion models. So you can see that most of these subjects are probably in the middle age range group. So you have very few sort of images of children and very few images of older people. And this was an earlier study done at Google, where they found that that demographic skew also probably might be influenced by a geographic skew as well, where you have the origins of these images. This is for Open Images and for ImageNet, sort of almost 80% coming from European countries and the US, overwhelmingly from the US, compared to other countries. So you have this cultural context too that really influences the data availability of representing these concepts such as healthy skin appropriately and fairly. So our solution to that for gender shades was the introduction of a new benchmark. So one that was balanced in terms of who we hope to see in the population that was being served. So gender shades deals is an audit effectively of a given binary task, which we had chosen as gender classification. So we audited commercial APIs for the gender classification task, and we audited these models on a benchmark that we created called the Pilots Parliament benchmark. And you'll notice that this benchmark is balanced in terms of gender, but also balanced in terms of skin type. And that means that even if you're serving, one, black female, that black female subgroup is proportionally represented in the benchmark that the model is being evaluated on. So that's the main type of bias that we address in gender shades, but I just wanted to give a super quick call out to other types of bias that I think are pretty interesting. One of them is the idea of representing different concepts and representing them appropriately, but then also thinking about context of use. So this was something that was discovered through the Open Images Extended and Inclusive Images project at Google, where they could see that if a lot of the training data is from this European context, then you can't necessarily use the same model in a different context. So the African context, a white dress doesn't necessarily mean a wedding. And then there's also the idea, the concept of looking at causality and which factors or which elements of the training set or the training data influences the output, and wanting to mitigate the influence of different inputs. So that's like another form of bias and discrimination that we see. I just wanted to give another kind of shout out to another form of bias that wasn't, this is not, those last two forms of bias weren't addressed in gender shades, but I just wanted to mention them. And this is another one I wanted to mention, which is the idea of label inclusion. So here is, a very, one of the most recognizable faces in Asia. He's a very popular Korean actor, but he's not included in this particular celebrity model. And we did audit this commercial API model, just looking at the demographics of the celebrities included in the model, and out of 10,000 celebrities that they claim to identify, over 74% of those celebrities are white celebrities. That's another sort of bias that wasn't addressed in gender shades, just to show that we audited a very specific type of bias. When we were finding the bug, we found a very specific type of bug, which was label representation and then looking at the data availability problem. So the second thing we looked at is sort of like, how do we report the bug? And this is related to work at Google on model cards, which is looking at standardizing the documentation for reporting the performance of a model with regards to the ethical consideration. So if you want to sort of train a model and deploy a model, what's the information that's necessary for other engineers to know and for the audience to know in terms of how appropriate the model is. So here's an example from the Perspective API model at Google, and they effectively found that if they create their own user representative benchmark, similar to PPB, and look at the performance in terms of unitary groups. So they look at, in this case, they're looking at concepts related to LGBTQ status and gender, and they look at intersectional performance. They can also figure out, they can identify and communicate about the classification bias in the model. Another thing that we did with gender shades, and this was probably the major contribution of the audit, of this type of audit, was following something that very closely resembles the corporate vulnerability disclosure procedure for security risks. So for example, if you have software that is dangerous, there's a very set procedure for how you report that software and how you communicate this to different companies. So what we did effectively was we followed a similar procedure for communicating about the biases and discrimination in different software and commercial APIs. So it's a very similar process where you document the vulnerability and you define sort of a period of time where you communicate this vulnerability to different corporations. After communicating it to these corporations without releasing or identifying the other corporations involved in the audit, then you give a public release and you name each of the audited targets. So we did that, and we sort of had similar results in impact. So the third question, which is the big one, is like, how do you fix this bug? How do you address discrimination and performance disparities in these commercial API products? That was really the big question of our follow-up study, actionable auditing. So in gender shades, we audited Microsoft, Faith++, and IBM, and looked at the performance disparities for different demographics on the PPB benchmark. And then in actionable auditing, we did a follow-up study, and we added two non-target corporations, so Amazon and Kairos. So the companies said that they were influenced by gender shades to make improvements. IBM, Faith++, and Microsoft all redeployed new commercial APIs after the gender shade study. So we thought, okay, let's re-audit these algorithms and figure out if there's actually been an improvement. So here's the overall accuracy for the target companies and the non-target companies. And this is on PPB, the pilot parliaments benchmark. And then here you see, for the target companies, the disparities in performance between male and females. So this is in 2017, in the previous audit, May 2017, you see that there was an 8 to 20% performance disparity, and that's reduced to 1 to 9%. We see that with the non-targets, however, that disparity still exists. So if they weren't explicitly named in the first study, even in August 2018, that demographic, that performance disparity still persisted. So we saw a similar thing with darker and lighter. And then when looking at intersectional performance, we really saw the improvements there as well, where between 2017 and 2018, you can see that, especially on the darker female subgroup, there's been drastic improvements. So this is Face++ another target, and you see that on the darker female subgroup, there's been an improvement from a 65% accuracy to a 95% accuracy. Similar thing for IBM. Whereas for the non-targets, and here I use Amazon as an example, that disparity still exists. So in terms of sort of preventing future incidents or whether or not that fixes the issue, we realize that, as you can see, if they're not explicitly named and explicitly going through the coordinated bias disclosure process, there's not been a lot of improvement in terms of their performance, the API performance. And if it's not been an explicitly audited company, then they don't make drastic improvements. So in terms of preventing future incidents, we really thought about what it was that these companies said that they did, especially the target companies that actually succeeded in closing the classification bias gap. So one of them was obviously, the claim to more diverse data sets and thinking about the diversity of their data sets. IBM in particular released a study called Diversity in Faces where they published over 1 million diverse faces to support the development of more diverse data sets in terms of training machine learning models that can actually address these classification bias issues. So a lot of the companies claim to have data be a huge part of their solution in terms of addressing this discrimination bug. Another thing that we saw a lot of companies do was set up different design standards and really start thinking about responsible AI development in a different way. So IBM, Microsoft, and Google all published these AI principles where they laid down very clearly what their design principles were and what the design standards were. And this really relates to the bug reporting process where now they require, with the deployment of their model, an analysis of these biases and a reporting of these biases. At an industry level, IEEE released the ethically aligned design a document, and they're coming up with more versions as well, where they think about how do we certify a model as ethically sound, and what can we do in order to communicate at an industry level what our expectations are. And same at a societal level. So New York City has a task force that they've set up, and Washington also is thinking about legislation to think about how do we enforce sort of strict standards and recommendations on how to think ethically about these issues and communicate ethically about these issues. But like I said, in practice, it's much more complicated than simply minimizing the classification bias of a particular model. Like I mentioned early on, there's so many different forms of bias, and there's so many different forms this bias can take, and it'll really require an interdisciplinary effort. And then the sort of final comment is that this really goes beyond just debiasing the model and minimizing the discrimination that the model prediction itself can make. Even if you have an unbiased model, you can definitely still use that model to discriminate against vulnerable populations and hurt different populations in different groups. So that's why Joy sort of set up this Safe Face Pledge and through the Algorithmic Justice League, where she looks at sort of these are the requirements that these are the sort of ethical considerations required with the deployment of this technology. Beyond just accuracy disparities, what other ways can this technology be misused? And how can we get people to sort of pledge towards not making that mistake? So thank you.